Shore hardness. Shore hardness test is one of the important hardness tests for measuring the smaller hardness material, that is polymer type of material. We can go for a shore hardness test. This shore durometer is a hardness measuring instrument which is used to measure the hardness on the metal or a soft type of material as per the ASTM D2241 standard. So this shore durometer is a device. It is used for measuring the hardness of the materials like polymers, elastomers and rubbers. There are two scales present here, that is Shore A scale and Shore D scale. In Shore A scale, the hardness of a flexible mold rubbers is measured. In Shore D scale, the hardness rubber, that is hard rubber, semi-rigid plastic and hard plastics are measured. Higher the numbers on the scale indicate the greater resistance to indentation, resulting in the harder material. The lower number indicates the softer material. So, in type A, the hardened steel rod of 1.1 mm to 1.4 mm with truncated cone of 35 degree and a diameter of 0.79 mm diameter is used. Under type D, the same type of the thing, but the angle is instead of 35 degree, you are going for the 30 degree, and the diameter instead of 0.79 mm, you are going for the 0.1 mm radius tip. So the applied mass is also different. In type A, the applied mass is 0.82 kilograms, and type D is it's around 4.5 kilograms. So it's in type A scale it is very less. You are applying only very 0.8, that is less than 1 kilogram. But in type D, nearly you are applying the 5 kilogram load. Take in the case of Shore A, there is a wide range. You can measure the hardness as extra soft, soft, medium hard, hard and extra hard. So under Shore A, you can have a scale of 0 to 100. Similarly, under Shore D also, you can have a scale of 0 to 100. So the hardness of different materials like jellies, rubber soles, rubber bands, right, and also polymer strips, rubber tire, shoe sole, and also the stretcher wheels, roller wheels, and also the hard helmet. Take the hard case of a hard helmet. Hard helmet measures 80 Shore D. That is 80 Shore D is nothing but it is the higher harder material. So beyond which there is no hardness. So in Shore D scale or Shore A scale, the maximum scale is up to 100. Coming to Mohs hardness, Mohs scale is a metric used by a scientist. So they determine the scratch resistance of different materials. So diamond is a material which is positioned on the top scale and it has a score of 10. And also the fingernail, our fingernail, it has some hardness of in the range of 2 to 3. That is rangely from 2 to 3 scale. The elements and alloys can fall in the metal hardness, that is 10. If it is 10 scale, we can tell it as harder material. If it is 1, value is 1, we can tell it as soft material. The hardness of the material, it is a Mohs scale indication. They have classified different types of materials like alkali metals, alkaline earth metals, basic metals, transition metals, metalloids, alloys, right? So these metals are used for different applications. In the area of application, alloyed applications, battery applications, electronic applications, chemistry or jewelry applications, nuclear applications, biomedical, automobile parts, and the many applications are used. So you have a higher order material, that is carbon, in the form, that is diamond in the form of a carbon. Next to carbon, diamond, you have boron, titanium carbide, tungsten carbide, chromium, and tungsten. So by comparing this, we can tell tungsten is the harder material. We know tungsten is the most harder material. It is used for making a tool steels. It is used for making tools. Similarly, chromium is also a harder material, and tungsten carbide, tungsten mixed with carbide, titanium mixed with carbide. So all the things forms the very harder material. but boron is a next harder material compared to diamond. Here, the next chart continues the Mohs scale from 7.0 to 6.0. You have vanadium, rhenium, osmium, silicon, ruthenium, tantalum, iridium, titanium, manganese, germanium, niobium, and rhodium. So each material has different properties. Then the hardness of uranium, beryllium, molybdenum, hafnium, cobalt, nickel, palladium, white gold, steel, iron, nickel, and arsenic. See, the arsenic has the 3.5 Mohs hardness and uranium has 6 Mohs hardness. So you can compare and tell uranium is a harder material compared to arsenic. And also you can tell steel and iron are mostly equally harder, right? Because it has the Mohs scale of 4. On the next material like platinum, brass, bronze, copper, antimony, and thorium, right from the aluminium, magnesium, zinc, silver, lanthanum, cerium, gold, tellurium, bismuth, cadmium, calcium, and gallium. So gallium is the hardness of 1.5. Take the hardness of gold. Here the hardness is 2.5. So while this gold is normally a softer material, it cannot be used for making the ornaments. What you are doing, you are mixing the gold with copper because the copper has the nearby hardness of 3. So while you mix some percentage of copper, 3 to 8 percentage of copper in gold, it makes the gold to work and also having some sufficient strength also. The next part of the hardness chart starts from strontium to cesium, where strontium has 1.5 more hardness and cesium has the least hardness of 0.2. So all these materials are used in different applications. Based on the hardness, we can select for different applications. So coming to this, you can compare the different hardness of different materials, and suppose if we want to do some go for a material of different applications. Take in the case I want to manufacture a locker, right? So what material I can select? What is the material which is of use now, and what is the material I can go? So I can have a complete list of properties. I can have the different types of other properties also. So I can compare with all these properties, and so that I can suggest one new material for making the safe or a locker. Knoop's hardness test. So this hoop hardness test is conducted as per the ASTM E92 and ASTM E384 standards. This test is similar to Bernal test and also it is similar to the Vickers test, which is found using the measuring the indentation using the microscopic examination system. So the shape of the indenter used in the Knoop's hardness test is rhombus shaped indenter. So this rhombic indenter does not produce a geometrically similar indentation. So the indentation depth is very shallow compared to the Vickers test under identical condition. So this makes the Knoop scale to be extremely useful for evaluating the hardness gradients of thin coatings from section samples. So the Knoop test uses test loads in the range of 100 to 500 grams. It is a generally low force since 500 grams means it's half a kg. So you are using only a very low force to find out the hardness of the material. The one of the importance test, one of the importance in the Knoop's hardness is we can go for a measuring the hardness of a material which is very thin or some small sections of 1 mm or 3 mm. So we can go for the Knoop's test. So this is the procedural thing, Knoop's hardness test what we follow. So we are having an indenter. The indentation angle is 172.5. The angle is very important. So sometimes they will ask what is the indentation angle of Knoop's, what is the indentation angle of Rockwell or Vickers test. So here we are applying the test force. This test force will create some indentation. So you are measuring the depth of the indentation H, and you are also measuring the width of the diagonal indentation, and also the length of the diagonal is also measured. And based on the formula, you can arrive the Knoop's hardness test. So finally, we are coming to the applications of the hardness test. So far, we have seen what are the different hardness tests, what is the procedure for conducting the different hardness tests, its advantages and disadvantages. Finally, we are going to have a discussion about the applications of the hardness test. What is the need? Why you want to perform the hardness test? This hardness test is used to find out the material properties like hardness. This hardness has an impact on strength, ductility, and wear resistance. If you measure the hardness, we can tell the information about the wear resistance. If you measure the hardness, we can tell the material's ductility. And also, if you measure the hardness, you can tell the material strength. So, this hardness is test will be useful for the applications like heat treatment. Suppose if you want to go for heat treatment applications, there are many heat treatment applications, annealing, tempering, or tempering, right? So where you heat the material and keep it for some time, then you cool it. Then after cooling, what you do, you measure the hardness, whether that particular operation has improved the hardness or not. Then this hardness test is used to evaluate the surface hardening procedure. In some operations, right, you take the example of lathe bed. So that particular lathe bed should have the sufficient hardness. It should have surface hardness only. The indent core is not a problem. Only the surface should be hardened. So what we are doing is we are measuring the hardness surface using the different types of hardness test. Then also this test is used in consulting condition and also R&D department. You are measuring the hardness for different materials and you are suggesting the new material. So this consulting and R&D is a similar case where you can have some engineering consultation. Because some engineering companies come with some problems. What these consultants do is these consultants will provide the suggestions or they will give some valuable inputs based on the engineering problems. So while some companies come with some problems related to hardness, they will do the hardness test and they will come to the analysis that they can have the alternate materials and they will suggest the alternate materials and they will also give some R&D ideas so that they can have a new alternate material, and it is also used in inspection and testing of products. Sometimes this hardness test is used for measuring the inspection. When companies there is quality control department, so this quality control department performs this inspection operation and also the testing operation. So under inspecting operation, what they will do, they will inspect the piece and test it and finally find out the result whether the result is in the level particular level or not. For this reason alone they are going for the hardness test. Finally, research and development. So the continuous usage of this hardness test, you measuring the hardness and you are suggesting a new material and you are going on improving the product quality is nothing but the research and development. For each and every company have the quality control department and also R&D department in their organization. This department will go on working with many measurement steps. They go on dealing with the problems, finding the solutions to the problems, giving the alternate materials and developing a new materials. So all the things will be done with the help of a research and development department. But all the things, all the departments, either heat treatment department or consultation, either the inspection department or R&D department, their main thing is testing. They test and they go for the new materials or suggest the